Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to do file I/O in C++. So we'll start off with File, New Project, and it'll be C++ empty project, which we'll call File I/O Demo. I'm going to set some linker properties so that when we run this program, it'll display the console. And now we'll add a new item, a CPP file, which we will call File I/O Demo. We'll include the standard things we need for a C++ program. We'll include the IOStream library. We'll use the standard namespace. And enter some information so that anyone looking at this program knows what it's about. I'm going to define my main function. It will return 0 to indicate that everything returned OK. So to write to a file, we're going to include, or we're going to define a OFStream object. And I'm going to call it that OFStream object output file. And this OFStream object, when we put the dot operator, first off, we need to include the FStream library. And now, when we put the output file, we'll start off by opening up a file which we're going to call example.txt. One thing to notice is if we put output file, hit the dot operator, we see that we have a number of functions associated with the type OFStream. So this dot operator will actually show you things that you can do that are specific to OFStream. and open just happens to be one of them. If you hover over it, it'll kind of tell you what it does. In any case, what we want to do is we want to take this output file now that we've opened it, and it's a stream object. So what we can do is we can use the same type of syntax we use for cin. Cin is also a stream object, and whatever we write to, or whatever we stream to the output file will be stored in that an example.txt. We can even stream multiple lines if we use the end line. So the same things you do with cin, you can do with this output file. And then rather than writing it to the console, what this will do is write it to within a text file. Now, after we write to a file, we always want to make sure we close it. Otherwise, that resource will stay open on the computer, and if you have too many of these open up, then it creates a problem. So we'll run this with Control F5. It compiles it, and it doesn't display anything because we didn't actually have it display anything. But if I go to my solution and I right click and open folder in File Explorer, and I open up the project file, we'll see that now this example.txt file is created in the root directory for our solution. And if I open this, what we see is sample text to write into file, and this will be on another line. Everything that we wrote into the program is now stored in this text file. Now, one of the things we could do is what happens if we try to open up a file name that couldn't be opened. And the way I'm going to simulate this is I'm going to give it a directory name that doesn't actually exist. So I don't have a Z drive on this computer. And if I run this, there's no C drive. Obviously this wasn't opened. And to demonstrate a little better, let's I'll open up we'll look in the file demo. I'll get rid of this example file and we'll run this again. And we'll see that nothing was created and there's no Z drive on this computer, so there is no way for this to have created. So what we'd like to do is we'd like to be able to check to make sure that the file is actually opened. And we can do that by making the following changes. We'll use an if then to check to see if output file dot is open. And you'll see, notice that with output file again, I hit the dot, and when I start typing is, I can see in IntelliSense that one of the functions that's available for output file is open. Because it's a function, I have to have open close parentheses. And I'll enclose the code that writes to the file inside of this if-then statement. And if I can't open out, I'll just display an error. So let's see what happens. It should get an error, or it should display the error message because it can't open this file. And sure enough, because Z doesn't exist, I get an error and it tells me couldn't open the file. So that's exactly the behavior I want. If I remove that Z and run it again, I can see that it does work. And if I look at File Explorer, go down into the file IO demo, which corresponds to the project, example.txt is open, and it actually wrote everything to it. Now suppose we wanted to write the time in our file. Well, the first thing we would need to do is include another library, and this is going to be the ctime library. And we'll need a time object, so we'll declare an object called time t, we'll declare a time t object called raw time. The time t class comes from the ctime library. And we're also going to declare a tm object. It's a time structure, which we'll call OS time. And then we'll do this function call. So we'll say time, and we'll pass in a pointer to raw time. So this is going to pass the address of raw time to time, which will fills raw time with UTC seconds. And basically what what will happen is raw time will now be filled with the number of seconds since January 1st, 1970, which for computers is the beginning of time. The next thing we do is call a function called local time and underscore s, and what this will do is we'll pass it a pointer to OS time, the address of OS time, and the address of raw time. And now what this will do is take the raw time and calculate what the local time is into OS time. And now what we can do is declare a variable called month, which will equal was time dot tm, so we want the month, and we add 1 because months are 0 base. So what this ostime.tm month will do is it'll take this time object called ostime, and it'll extract the month from it. Next we take day, and that mday will return the day of the month. And you can see when we hover over that day of the month, it says day of the month. And then we want the year, so that will equal time dot time of the year plus 1900. Since beginning of time starts in 1900, we have to add that into the year. So now int day and year will have the month, day, and the current month, day, and year. We can also get the hour. And now give me hours between from midnight and the minute, which is the minutes after the hour, and seconds. So we have month, day, year, hour, minutes, and seconds. And what we could do now is in our output file, say timestamp, display the timestamp, and we'll say month, day, and then year, I'm going to put this on a second line, but it'll all show up on the same line because you notice there's no end line here. And then we'll put in the hour, minute, and second. And finish here with an end line. So these two output lines will be all on the same line. It'll just be the month, the day, the year, a space, and then the hour, minutes, and seconds, all on the same line. Let's see what happens. So program worked. We're going to then go and open the folder in File Explorer, File I/O, open, and we can see that we get a timestamp. So sample text stored file, this will be in another line, and here we have timestamp, month, day, year, which is the current month, day, year, and So we got the month, day, year out of here, and then we got our minutes and seconds formatted the way we wanted. Obviously, we could set the display width to make it be 0.5 if we wanted to, but this will work for our demonstration purposes. So that's how we can get the time out of OS time. Another way we can do this is actually we can also declare a character array. We'll call it time now, and we need a character array for time and another character array for date. And then what we do is we need something called an error number. We'll see what that's for in a second. And we say error is equal to string time underscore s for short, I believe, and we pass it the name of the array, which is actually a pointer, but we'll discuss that later with arrays, and the number of characters in that array. And again, we will call string time or string date underscore s, and we'll pass that date now with the number 20. And what this will do is it will I misspelled these. It's actually underscore string time and underscore string date. What these two functions will do is it will fill time now, this character array, with a representation of the time, and date now with a representation of char. You'd normally think that we could make these strings, but this function was defined with character arrays, so it's probably there's a function that was defined before C++ and implemented strings. But now that time now and date now are filled by these functions, which we got from the ctime library, we can actually display them. So we'll just display them like this. So on this bottom function, we'll just display time now and date now. So this is get time using char functions. And everything here is get time using time function. So it's just two different ways. And now we'll save to file. So we ran our program. It appears to have worked. We'll open up our solution, the folder in file view, go to file.io demo, and edit example with a notepad, and we can see both of these approaches did the same thing to get the time. So you can use either one of these approaches to get the current time and put a timestamp in a file. So here we see 10:35. So let's close this out, and then the next thing we'll do is let's break this into files. So rather than having, we'll settle on one way of getting the time. And I'm going to create this as a file. So I'm going to say function, or I'm going to declare a function that will return the time string. I'm going to say make it a string function, and it will be called get time, or let's call it current time. And since we don't really need to pass anything into it, we'll make it parameterless. And I'm going to take this code here and we'll just return a string that's composed of date now plus time now. Of course, we can't really add these together because they're strings, so we'll declare a string stream object, which means we will need to include a string stream, the SStream library, in our current time function we'll get a string stream object, we'll call it time stream. That sounds kind of cool. And once we get time now and daytime, we can stream date now, just like we did for our output. We can stream these objects to the time stream, and then what we'll return is timestream.str, which is the str function for a string stream object. Will actually turn time stream into a string. So maybe a few comments will help. Then we get the time. Return a string, and then I'll just put some comments here. So that's one function we built, and so we don't really need all of this anymore. So I'm going to get rid of these time functions which I defined before, and we only need one display of the timestamp, and so I can just use my function that I defined. And so now this save to file will use the current time function we defined to display it as the timestamp. If I run this, let's see if it worked. Got an error. And looks like I forgot to put my function prototype at the top. So we'll quickly do that. Let's try it again. Looks like our program ran. And we see that our timestamp function seems to be working pretty well. By breaking it up into a function, I take this slightly complex code and simplify main. The next thing I could do is I could also make the save to file function perhaps a little simpler, and I'll make a function that will be save save information to a file. Just putting in some comments so that I know it makes it a little clearer where these functions are located. And this will be a void function. We're actually going to, its output is going to go into a file, not anywhere else. It's not returning anything. Although we could, let's say we'll return a Boolean. That might be a good thing to do so that we know if the file actually opened. And we'll call it save file. And let's take a parameter which is a string for a file name. And we'll copy this code for now, repurpose it. So rather than using example.txt, we'll just use the file name that's passed in. And we'll open the file. Here's the stuff we want to write. Notice that it save file information calls current timestamp. So what I might put in my comments is calls current time. That way we know that this function is dependent on that other function. And rather than couting anything, what we'll do with our function is we'll declare a Boolean, call it file OK. And we'll assume that file is OK, so we'll set it to true initially, and rather than couting, we'll say file OK equals false. So if it works, file OK will be true. If it doesn't work, it'll be false, and what we return down at the bottom here is file OK. So what this will do is when we call the save file, we'll have a if then that we can check to see if the file was OK. And if it works, it'll store all this information. And rather than doing this, what we will do is we'll just call our function now. And in main, it will make this instead like this. We'll get rid of that. We'll call our save file, and I'm going to call it example2.txt. And if it does good, we'll cout just say that file was saved. And if not, it'll just display an error. So the way this works is, since save file returns a boolean, we can actually check it in an if-then statement. We don't have to set we could declare a boolean variable and set the result to equal save file, but it's just as easy just to place save file in here. This will go in and save the file under the file name, which we're going to call example2.txt, and then if it works, it'll say file saved. If not, it said it couldn't open file. And again, of course, we have to put our function prototype at the top, and let's run it. And we see that it worked. It called save file, it went through everything that save file does, returned true, which then ran the cout, and that displayed as file saved. And we can see here it must have put a timestamp, put all this text into the output file. It was opened successfully, and so we got file OK. Let's take a look and see if it actually saved it. There's example 2. So I'm going to edit that with Notepad++. And we can see we got the timestamp and the text we wrote. So again, this worked pretty well. Now suppose we wanted a function that we could use to read a file. What we can do is we're going to declare this yet another function, and we're going to call this function read file. And it's going to return a string, which is whatever was in the file, and it's going to take one parameter, which is the name of the file we want to read. And rather than an OF stream, which we did when we output the file, we're going to use an IF stream object, and we're going to call that one input file. And I'm going to have a string called line and a string called full text, which I'm going to initialize to an empty string. And we'll see why in a second. So I'm going to take this input file and I'm going to open, and I'm going to use the file name that's passed into the function. And if the input file dot is open, just like with the output file, we want to check to see if it actually opened up, because there may not be a file that's named by the file name that's passed in. Then I'm going to do one thing, else I'm going to do another thing. And the else is I'm going to return, I'm going to set full text equal to error could not open file. If it does work, then what I'm going to do is I'm going to loop through this file that we opened up. And the way I'm going to do that is there's a function called, I'm going to use a getLine. This is the same thing as the getLine that you've used before for text, but rather than using a rather than putting C in here, I'm going to put the name of the file, input file, and a line. And so what this getLine command will do is it will look into that file and read every character it can until it gets to a carriage return and pass that line into this variable string here, which we called line. course, if I use getLine, then I need to include the string library. And actually we also, I think, need to include the ifstream library, or iStream. So we've got our getLine input file, our line, that brings in one line at a time. The next thing that we want to do is we're going to concatenate each of these lines into this full text string. Now if we just brought in each line, the line string will not be brought in with a carriage return at the end. So we're going to add /n to the end of each line so that we have a carriage return at the end of each line. And at the end we will return full text. So again, the way this works is we needed the fstream and the string libraries, and we declare an ifstream object called input file, line, and full text strings. We open our input file using the file name that's passed into this function, and then if it's open, we'll loop through each line in the file using this getLine command. And we'll take the line that we get with this getLine command and concatenate it onto this full text using this += command. If we can't open the file, we'll just return error could not open file. We'll return the full text, and within our main function, we'll open and display the file using this new function that we've used. And basically string file str, we'll declare a string called file str and assign it the outputs of read file, and we'll use example 3.txt, and I'm going to save to example 3.txt, and then we'll just see out the results of that file just by seeing out a file string. Or actually, I'm going to change this to file text. That makes more sense, I think. So what this code does is it calls read file. Read file will open up that file. We'll get all the lines from that file. We'll assign it into file text, and then we'll just output it. And of course, once again, I forgot to put my file prototype at the top, so we'll copy that and place it up here. Build it again. And we can see it looks like it worked. File saved. That came from here. Information from the file. So if I scroll down and look at what was actually written, we can see sample text to write into file. This will be on another line. There's the timestamp. And if I go look at that file, here's example 3.txt, and we see that that's in fact what was displayed. So this file was read by the program and displayed here in the console. Now the last thing I want to do is I want to take all of this and put it in a separate file. So I'm going to add a new item. I'm going to add a header file, and we'll start off our header file with an if and def and underscore file io demo underscore h, which is our normal definition, the normal token we use for our files. And I'm going to, well, actually, since this is going to be functions, we'll call it underscore functions underscore h, and we'll use define again, same identifier, and end our if. Next, we'll take file io demo and take our function prototypes and place those into our header file. We also need to include and we also need to use we have our includes, we also need to have our namespaces. And if I look at this, I need string, but I don't think I need anything else here. And so there's our header file. I'm going to put a comment header in it as well. And we'll just say functions for file IO, I think. We'll save that, and that's our header file. And then we also, and I'm going to rename that functions.h. I'm going to then add a new item, and it'll be the CPP file, which I'm going to call functions.cpp, and we'll take all these functions that we defined, and we'll put those in our functions.cpp. We'll add our prototypes and our header. Actually, this block probably works better. So there's our function definitions themselves. We need to include a reference to the header file. Remember that we use a double quote rather than a less than or greater than sign when we reference a functions.h. We also need to add that to our driver file. And if I look at this, I probably don't need all of these except for stream. I do need include IOStream. And the reason we could delete all those is that those libraries aren't actually used in main, they're used in our functions, and we included those over in the functions.cpp. So we could clean that up. The other thing that we can probably might be able to get rid of that, but I'm going to just leave that for now. And I'm going to see if this actually works. And it does. So now we've split out our functions into a separate CPP and .h. File IO demo, which I'm going to rename to File IO demo driver. That just kind of lets people know that that's where the main is. Still runs. And so we have a nice, clean, simple program by moving all the functions into a functions.cpp and a functions.h file. And that concludes my demonstration of File IO. Thank you very much.